Hello, hello.
Hello.
How you doing today, Dev?
Are we starting now?
Yeah, we're started.
Oh, didn't like press record, but
Yeah, we got up a little
nice. So, hello. My name is Devin Austin, and this is,
Duncan Tulimieri.
and we are both TAs for the 2024 cohort of Reaper Rehab. So, Reaper Rehab is a sort of a specialized program to help bring in
Before you keep
individuals.
going, can you share your screen?
Oh, I'm not sharing my screen.
Not yet. We got the website up. We just want to make sure you guys know what we're looking at.
All right. It's kind of similar to if I were to like TA my class, I can be like, can everybody see my screen? And everybody goes every single time. So this is the Reaper Rehab website. And Reaper Rehab is sort of a specialized program that's geared towards providing researchers in the rehabilitation field with skills and knowledge to essentially help make more reproducible data science and make their research more reproducible. So
Because we are never really formally taught these
we are
things.
never formally taught these things.
So that's what this program is really trying to do.
Mhm. And the program does that in a few different ways. We've kind of briefly gone over the vision, and I'll just highlight the grant number just to really point that out. But the program provides these tools in essentially two different ways. The first is by having TAs like Duncan and I to help come in. We are both given a set of 6 or 7 individuals to help teach and coach through a couple months to help build a reproducible project or help them learn programming skills.
Yeah. Data science skills in general too.
Exactly.
You know, because like Git and stuff is taught as well.
Yeah. GitHub is not always the most intuitive, at least for me.
Definitely not.
So we do have courses and TAs that can help teach and help people understand that.
And implement it to their research.
Exactly. Another thing that Reaper Rehab does is help build a database of resources to help pass on to future generations, so you don't have to necessarily apply for the program. Get rid of that tab, we're already going. You don't have to necessarily apply to join the program, but you can also still use these free resources that we offer to you. But if you would like to apply for next year's pod or next year's applications, they open March 15th and close May 1st. And this is not just for students looking to learn, but also TAs as well.
It's a great recap. And the website is super friendly. You know, if you guys want to go on there and check it out, if you're curious, it's pretty intuitive, and you can look at the databases. You can also look at the blogs, which are fun. Yep, it's got this nice database. The Repro Rehab DB's got like all the videos and the stuff that you can look up. Yeah.
Some courses, some videos. I think they also have some data sets too you can use for even machine learning projects or just like small data sets just to get started with and kind of get your feet wet with reproducible science.
Yep. Do they have any data visualizations, one?
That's a good question. These are data sets, like a database course.
Oh, there's one.
Yeah.
JSON. Interesting.
Oh.
I don't see any for MATLAB and Python though.
Well, I guess that's why we're here.
Seems like there's a gap.
That's why we're making these videos today.
We found the gap.
Well,
That was a great intro.
it's time to fill it.
I think so.
Okay.
All righty. Let's talk about what we're going to do today. So the basics of what we're going to do today, we're going to, we have an idea for these figures we want to make. And so we're going to draw it out, and then we're going to make that drawing into a real thing via code. Devin's going to do it in Python, and I'm then going to show you guys how to do these similar things in MATLAB, and how I'll talk about some of the differences and the similarities between MATLAB and Python.
And we'll kind of keep an ongoing tally of ways that Python is a bit more convenient than MATLAB and vice versa too. So look forward to that.
Yeah, and then at the end we'll see who wins. All right, let me share. So the first thing that is critical when you want to make some figures. Or at least that I think, and Dev, you tell me if this is kind of how you go with this too, but if you draw it out, then it's really easy to make the figure because you have something to check against what you're doing. And then you can also show it to people and say, is this exactly how you want this to look? Or were you imagining that, this is not how it looks, or did you want it to look a different way? And that way, takes 2 minutes to do a drawing, but it takes a lot longer to write the code in order to make that into an actual publication quality figure. That can be used. So it's a nice, easy way where you can kind of hash out some of the details early on.
Yeah, I think it's really nice to envision what the end product is going to look like,
Yeah.
even if it's just a quick drawing that you have. Because I feel like it makes the journey leading up to it just a bit more clear. You have more intuition about what to do or where to add it.
Yep.
You know what it's going to look like.
And then you can really, like nail down all those little aspects about the figure beforehand.
Yeah.
So correct me if I'm wrong here, but what we're going to be doing is we're going to be creating a figure to show programming confidence improvement from before repro rehab to after repro rehab.
Yes,
That's
we have
correct.
essentially created a fake data set where we have taken some learners from before they started Reaper Rehab and after, completely fake data. And like you said, just to test their programming confidence,
Okay.
see how effective Reaper Rehab is.
Whoa. Let's redo that. So then we said it's programming confidence.
Yeah.
Program main confidence. Is that, and this is going to be a percentage, right?
Yeah.
I'm thinking about that correct. And so let's put that 0, 100. Let's get me out of the way. Whoa. And we said we're doing it from pre-repro rehab to post.
Yes.
So like those would be some marks there. And what do we expect to find?
So early on in the pre, where we have people with minimal-ish programming experience, we expect the confidence just to be a bit lower because they're still trying to get their feet wet, still trying to understand what's going on. And then a couple months later, post-Reaper rehab, after they've had great TAs like Duncan and I, we expect that programming confidence to be
Sky high.
100 the entire time.
Sky high.
Yeah, sky high.
How do we want to visualize this? Because we got basically a distribution for pre and a distribution for post, right?
Yeah. So there's a few different ways that I like to visualize things like this. I tend to use box and whisker plots just because it tends to be a bit more descriptive with our data than just like a bar. So let's start with some box and whiskers.
So like something like that.
Like just telling me what to draw.
It's nice, huh?
It's very convenient.
Yeah.
Another way to be descriptive, or a way we can be even more descriptive, or what's the word, open about the data that we have, is to just plot the actual data points we have. So go ahead and
It's like little circles, right? Little circles, little squares.
circles. We'll
I'm even jittering it for you. Look at that.
We do like to jitter it because sometimes if I were to just too much is right. There we go. Nice. We like to jitter it just because sometimes points can overlap on each other, so then it defeats the purpose of seeing the actual data points if you can't actually see them.
Exactly.
So
I think that's, what were you gonna say?
Well, just kind of looking at this, I'm kind of interested in seeing like the average, like how well did people improve?
Yeah.
And I think one of the ways we could visualize that.
Do we want to save that for?
Fine, we can save it for the video. So this is
teaser, that's a teaser.
But for now, we will just try and make this figure in the first video.
Yeah, through Python and create the pipeline so that it can be updated as more data comes through. Nice. Thank you for help with the drawing. Of course.
Okay.
Alrighty, good sir. I think you're supposed to take it away.
So let's start with some Python. And get rid of my editor just to get the full code. One thing I'm gonna do is I'm gonna import a library that I know I'm gonna use and use that to adjust my zoom. Make it a bit easier.
Yes, there we go. Never too
So
much zoom.
I'm gonna leave a series of comments here just to keep myself on track, but the first thing that we need is just to generate some data. So generate data. I hope I don't make any typos.
I'll catch them. I'm watching, of course.
So in the figure that we made, we had some pre-data, we had some post data. And I am going to generate this data. How do I want to generate this data? I could use a normal distribution. Let's just go uniform distribution.
Yeah, uniform seems about right.
I can do that. I'm going to do numpy.random.uniform
Makes sense.
with a low equal to, say, the lowest confidence in the pre-group is going to start at 0. And their highest confidence would be maybe 55. And next we need to specify the number of participants. And if I remember right, we're 53 people in this year's cohort. So, and participants and learners. I like that better. Is that 53, 54?
53.
53. 53 learners.
It's nice. It makes it a bit more readable.
Yeah. And let's do the same thing for the post group. Low is going to equal, let's say the lowest is going to be 75.
That's a nice improvement right there.
100, we'll have some super learners.
Super learners, I like it.
And the size is going to be the exact same size.
Nobody dropped, nobody came on.
Nobody dropped, nobody came on. Everyone's scoring a bit higher. So let's run it, see if I made any mistakes.
I'm lagging a bit on my end, just to let you know.
Try and go slow. Yeah, I think we good. No errors,
Nice.
no fuss.
Nice, nice, nice.
So we have first generated our data. Now let's make the plot. Let's plot our data.
Let's make some boxes.
Make some boxes.
Box and whiskers.
So we are going to need another library to plot our figures. That's going to be the common matplotlib.highplot. And we're going to import it as PLT. So we don't have to write this every single time. Matplotlib.
There you go. I didn't even catch that. I didn't see it at all.
Too fast.
Zooming.
Wait, tell me to slow down.
Yeah.
Okay. So let's just create a basic figure first.
Yeah.
So this is really just going to be plt.figure. Give it some parentheses. And whenever I create a figure or an axis within a figure, I always like to assign it to a variable in case I need to call it later or change something.
That makes sense.
Oh,
Yeah, sounds. I don't see any figure.
Yep, I ran it and no figure actually came up.
Why is that?
So in Python, when you use the matplotlib library, you always need a little plt.show to show the figure.
To open up the figure to the foreground, so you can actually see it.
Still won't see my figure, huh?
Yeah, I'm not sure if you're sharing
You guys share the whole screen.
the desktop.
Okay,
Rerun it maybe.
Yeah.
Is it wrong?
Oh, so. There it goes.
There you are.
Just little bad.
Yep.
Don't be afraid to slow me down.
Yeah, I'll let you know.
This is gonna show. our
Nice. So we
figure.
have the figure, and now you're gonna just put some. First step is just to get the boxes on, right?
Yeah.
We're gonna start basic and build our way up and then come back through and really try to make it look nice. Not only the figure, but also the code that we use for it.
Yeah.
Okay.
So I think there is a few small things to do to finish creating our base framework figure. And that is to create a axis within the figure.
Mhm.
And this is kind of like the canvas for putting on the framework that is the fig,
So fig is the
like the easel
easel.
for painting.
Yep.
And the axis is the canvas we're resting on.
Yeah, because you plot things onto an axis.
Yes, plot things, you paint things onto the axis.
That's very nice.
So let's give this a descriptive title for our box plots axis. And this is gonna be our pre-post. It's a bit long, but it is informative, so we know exactly what's going on this
Mhm.
axis. And so many things. So to create my axis, I'm going to be using a little sub method within the matplotlib library. And this is going to be the subplot to grid.
Oh, I forgot to put our music on.
Yeah, turn it on now.
I know.
Oh, wait. I guess
You keep going.
so subplot to grid is very similar to the default subplot. But it just makes spacing a bit easier. You can also specify things like subplot row and subplot plot column. So if we wanted to split our axis canvas up into a series of rows and columns, we can use subplot to grid to specify that.
What's the advantage of setting it up this way?
So let's say I wanted to create a series of axes within a row. And we wanted to have 3 columns of things with only 1 row.
Mhm.
Could easily specify that here.
Yeah, it lets you adjust it a little bit easier.
Mm,
Interesting.
Very convenient. So let's give it a subplot row and a subplot column. Yes. Paired together. And because I have named, zoom out just a little bit, because I've named this axis, I need to specify the location within my grid. That location is going to be 0, 0. So essentially the top left-hand corner.
Mhm.
So if I plot this,
Let's see.
how it's changed.
Now we should have an axis on the figure.
Yep.
Ooh, very nice. Why is it so squeezed all the way to the left?
Because I specified for 3 columns.
Ah, I see.
If I were to copy this, make a pre-post 2, and change the location, so row, column, and I wanted it in that 3rd column position, 0, 1, 2, as in Python.
So the middle, if you run this, the middle should be
Middle
empty.
should be empty.
Very nice. Very nice. Very nice.
Very convenient. You
Yeah, but for right now, we just want one, right? Yep.
just won't.
Makes sense.
And let's plot it to make sure it looks the way you want. Yep.
Very nice. Very nice. Good way to start is right.
Wow. So we have our axis. It's time to start painting or filling it. So I'm going to specify our axis again. Do a dot box plot.
Easy enough.
It is very
I like it.
So right now we just need to specify our X data.
Like where on the x-axis it's going.
So with the box plot, this X is kind of, what's the word? Doesn't necessarily mean X. It's more like all of the data.
Oh, it's not like x-axis location. It's like
Like if I
X
give it a
data.
series of data sets,
Mhm.
it'll put the first data set on the x-axis 1, 2, 3, 4 for each different data set.
Okay.
So it's convenient in some ways, but it can kind of
Can be a bit confusing.
can be a bit confusing.
Once you use it though, it seems like you know.
Yeah. So one thing I'm gonna do just to make my life a bit easier down here, because this takes in a single data set,
Mhm.
I wanted to take in my pre and post data.
All concatenated together.
All, I wouldn't say concatenated. I just say packaged together. Is that concatenated?
I think so.
Okay.
I know concatenate's a MATLAB term. I'm not sure if it's a Python term as well.
There is concatenation, but I always associate it with like,
I know pandas got, yeah, that's what it is, right?
well, this is like, boop, boop.
That's just the row concatenation versus the column concatenation.
See,
I think it is a programming term.
it is.
Somebody who knows more than us will need to tell us if it's a programming term
Leave
or
a
not.
comment down below.
Yeah, leave a
Start
comment.
writing
Yeah.
in Python.
Oh,
So we specified our data. We have our full data set with both pre and post inside.
let's see it.
Let's see it. Okay,
Very nice.
got our data set.
That was very close to what we wanted it to look like
It's getting closer.
already.
Bit by bit.
Nice.
I think the one thing we're missing, or I guess the next logical step,
Well,
we
what are you
are-
gonna do?
well, we're being a bit descriptive by using the box and whisker instead of bar plots, but
Mhm.
we can be a bit more open about our data. So I think I'm just gonna plot the data first.
Can I do the box and whiskers in MATLAB first before you get too far?
I'm on a roll.
And it takes me too long to catch up. Thank you. Appreciate it. Let's switch over to MATLAB. Whoops. All right. So I've got this nice MATLAB script open, command window, and now I am going to try to basically do the exact same thing that Devin just did, but in MATLAB. So let's start with the title, visualizations. I always start with the clear CLC. And then I like to specify the path that I'm using. So I typically call it code folder, and that's going to be the directory that we have here.
Do you have to specify the code folder?
No, you don't have to. You can, the reason I like to do it is because sometimes if you have code in one place and data in another place, you can easily switch back and forth when these long strings are variables, are smaller variables than when they are just the whole long string. I think it makes it a little bit easier to read, and you know, if somebody were to run it on their device, in theory, if you set it up right and you just change the top paths, then it should still work. Let's run it, make sure it works. I think it ran, it just runs really quick because nothing really happens. So let's see, code. I'm gonna CD into the code folder. Yep, still working. And now, yeah, let's also close all figures, because when we're making figures, we want them to close as we run it. Let's set up, do some simulations. So we're gonna simulate data just like Dev did. And first thing I'm gonna do is write out constant variables for all of the different numbers that we're going to use for this. So I remember one is number of students, number of learners, and I believe 53. And then we have the the low value for pre-repo rehab and 0,
Yeah,
0,
the high value being 55.
high pre is 55. Low post 75
Yes.
and high post 100. All right, so now we've got some variables set up. Let's make this a little bit bigger. And now we can simulate some data. So let's do data pre, and we're going to do uniform random is what you had it, right?
Yep.
There isn't a nice function in MATLAB, a MATLAB inherent function, I guess, to do uniform random. There is an equation though that they provide. So
It's kind of convenient, but
inconvenient, yes, but just because they don't write a function doesn't mean you can't write a function.
Yeah.
And that's a little teaser for later.
mhm.
So it's the min. So let's do low pre. Yep. Plus the difference between the max. So high pre minus low pre. Do element wise multiplication times the random number. And this is going to be, I'm going to do a row vector and learners. See if that works. Nice, no errors. Do the same thing for post. So we got low post plus high post minus low post. Element wise multiplication, random numbers, 1 by n learners. Still no errors, I like it. We've got some data. Now we are going to visualize it. So just like Devin made an instance of the figure object, I am going to do the same thing. And it's pretty, I'll show you how to do the same thing. We don't actually need to do it for ours. So you could do fig equals figure.
You don't need to import a matplotlib library like I have to.
We don't, because all of our libraries are already imported when you
It's
on
convenient.
startup. It is.
That's pretty convenient.
Oh,
But you got a lot of libraries you don't use too.
that is true. That is true. Pros and cons for all. So here I've got the figure. I didn't even have to say PLT show. I didn't have to tell it to show. It just comes up, which is nice. So next step would be to actually get some paint on the canvas. And how we are going to do that in MATLAB is use the box chart function. And there are 2 functions you can use in MATLAB as of now to do box and whiskers, and that's box plot and box chart. I prefer box chart because I think you can edit the elements of the box chart a lot easier. And there's a lot more things you can edit with the box charts than you can with the box plots. So here we have to give it X data, which is just going to be 1 because we just want for the pre group. And I'll say data pre. And I know I'm going to error out here because those vectors need to be the same size. Yep, X data must be the same size as Y data. So we're just going to repeat the element of 1 by n learners. And this is another nice instance where it's good to have these types of variables to define your numbers so that you can use them throughout and you don't have to remember in your mind how many people, how many for this variable, how many for this other variable. And it's also nice because if you ever want to make a change, you can just make one change and the rest should follow. So let's see if this works. Yep. So here we got our first pre-group on there. And what we're going to have to do is put the next group on.
You have to do a box chart for each one.
Yes. There's probably a way I could have concatenated and done it, but
I'm not sure.
I like doing it this way. There's so many ways to do everything when you are programming.
Mhm.
So here we see the post group, but now our pre-group is gone. And that's because we didn't hold on to this axis. So what I'm gonna do is I'm gonna say this AX variable, get the current axis, and then I'm going to specify the target for both of these.
What do you mean by target?
Target is like the target axis to plot on. And this is nice because if you have multiple figures or one figure with multiple axes, you can say, I want to box plot goes on this one and then on this one. Otherwise, it'll just plot it on whichever one was used last. But sometimes you want to switch between them in different ways.
So when you make a figure, it automatically comes with an axis and it's just.
It doesn't actually.
Oh, so this creates it if there isn't one?
Yes. So like, let's check it out here. This is just blank figure, just like you had no axis.
Mhm.
If I say get the current axis, this will create an axis. Also, if I don't say that, but I plot on, if I do any type of plotting command, it'll first create an axis and then it will plot onto it. But we want it to be specific. So we're going to say get the current axis, that's the axis, and we're going to put both these on. And after I put one on, I want to hold on to that axis, meaning I want to be able to keep plotting and adding elements to that axis. So this should give us our two bar charts. Not bar charts, box charts. Box charts. And so I think this is pretty much what you had at that point as well.
Mhm.
And so our next step
Is to
Add
start
data.
adding some raw data to it.
Yep.
Maybe start cleaning this up, making it look a bit more
cleanup
pretty.
comes after.
like after the raw data.
Yeah, get the raw data on,
Raw
and then
data.
I'll get the raw data on,
Yeah.
and then we clean it up. Then we'll clean up, make it all look nice. Not only the figures, but also the code.
Yeah.
All right, let me stop.
And let me take over. Back to the entire screen, not just the scripts. Cool.
Give it a run.
Yeah.
Make sure no typos.
It's always good to come back to your code and run it just to make sure everything works the way you left it.
Mm-hmm.
Or in case I accidentally press it.
Ooh, mine have colors. Yours don't even have colors.
Mine do not have colors.
Not yet.
Not yet. But that will come later once we start cleaning up, making it look a bit pretty.
Yep.
Kind of like the drawing you made for us.
Yep. Makes sense.
So let's add some data. And I essentially want to do a scatter plot on my axis. But now this is kind of like a box plot and a scatter plot. So I'm going to rename this to just axis representing my pre and post. To be a bit more clear with what we have and where we are going. So applying the scatter on top of the box plot is kind of not super intuitive at first. We are going to need some X data and we're going to need some Y data. The Y data is going to be the data of the pre and post that we have.
Oh, you're gonna do them all at once?
Let's just do it one at a time first, just for an example. And the pre data is going to be our Y values, and the X data has to be just ones since the pre data is in that one.
This is like the actual X value that you want it to go on.
Yeah. Like if I bring my figure back up, I want to create all of the raw data points along this line right here.
Yep, that makes sense.
And we can't just say one, because similar to the error that you had before, everything has to be the same size. And right now, this is 53 learners, and it should give us an error if we just have this one right here. Yep, and error.
X and Y must be the same size, just like I got.
So one thing we can do.
What are you thinking?
I was thinking about just using something really similar to this uniform distribution, but we just need it to be ones.
Yeah.
So I could just
You got a NumPy repeat or something like what I had?
I am going to do something a bit simpler and have the X data for
Simpler than repeat.
and P dot ones.
Interesting.
And I'm pretty sure I can just give it the shape, and the shape is going to be 1 by n.
Another nice time that that variable comes in handy.
And let's just see if that works by itself first.
Mhm.
I'm not confident that I have these arguments right, but
I think that's right. Yeah,
I
it's
think we're
two.
good. Nice. Yeah. Now let's put it in here for our X data free.
Always good to check regardless.
You never know when it might come up. Nice.
Very nice.
We got our raw data. It's a bit on top of each other, but we'll clean that up later.
Just a tad.
I think now we're gonna have to do the exact same thing for the post.
Ooh, copy paste.
Do a little copy paste. We'll come up with some alternative methods for that later. Post, post, post.
You're putting post on ones too?
So this is where,
Whoa.
get rid of that. Where that is. So in this instance, this is going to put all of the post data in the exact same ones position.
Mhm. On the where the pre-data is.
So it's just gonna lay on top of each other.
Well, it should be higher, right?
Yeah, it should be a bit higher. But we just want this to move on to the 2.
Just gotta move that to the right.
So an easy fix is just to multiply our 1s by 2. Gave us an array of 2s.
1 times 2 is 2.
2 times 2 is 2.
1 plus 1 is also 2.
1 plus 1 is also 2. You can also demonstrate that too if you want.
No, it's okay.
I will do the plus 1.
You don't like the multiplication?
I said simpler, so really
Addition.
emphasize the simpler.
I like it.
I'm pretty sure I learned addition before multiplication.
100%.
So we have now added our raw values in different colors.
That looks nice.
Different colors.
The orange on the 2 matches up at least with that median line.
Yeah.
It also looks like it's all behind it.
Slightly different, and it is all behind it.
That's so weird. It's behind the
Behind some things, but over other
yeah,
things.
like it's over the median line. Maybe, I guess. We don't really know because it's orange. Oh no, it's behind everything because you can see with the blue. Yeah, that'll be something to get through.
But we have our raw data.
You got data on. Yeah.
It's not the prettiest, but
Doesn't
it
need to
is
be.
better than what it was before. So I think we'll turn it back over to MATLAB to
Do the same thing.
do the same thing.
Get some data on the figure. I like it. Okay. Thank you, good sir. All right, let's get some data on. First, we got to run it. We got to make sure it's still working. Okay, looks like it's still working. Now let's do some data. So I'm going to use scatter just like Dev did. When I said we want to put it on that axis, and then 1 and data pre. And let's see if this works. I don't know if it's going to let us do the scalar one. Oh, it does.
Nice.
Would you look at that? It's all different colors. Okay. And let's do a little copy paste just like Dev to right on the post. Boom.
Nice.
Nice, but ugly. We gotta make this look better.
Different colors are kind of cool.
I
That's a little vibe
guess.
to it.
I guess a little bit too small for me. I can't see that well.
Yeah.
So now I think first step, make the figure look nice.
Yeah.
Second step, make the code look nice. Go back through the code, see areas where we could improve.
Yeah.
Okay.
Yeah.
I'll hand it back over.
Back to Python. Let's start beautifying our figure.
Beautify it.
Cool. So we have our figure. And while we're here, we can just point out some of the things that we could easily
Yes,
fix.
that's a good idea.
We can add some labels
Mm-hmm.
to our X axis and Y axis.
Yep.
We can replace this 1 and 2 with the actual pre and post.
Yep.
Um,
Per programming confidence percentage on the y-axis.
yes. And maybe just adjust.
You want us
the
to just start
sizing of
there?
it,
Yes. Yeah. Get the size a little bit bigger so we can see the text
and then start messing around with the data.
Yep.
So
and
first,
the
let's put
colors and
outside
yeah,
coming.
big stuff first.
So I'm gonna specify some things that I know we're going to need in the future. So we want our Y label to be, what was it, programming confidence?
Percentage, yep.
Programming confidence percentage. Confidence. And it's gonna be a percentage. We're also going to need, I don't think we're gonna need the X label, but I do want to replace the X. So X
Yeah, the 1 and
X
2.
label. And those are going to be pre. And I'm gonna be fancy.
Oh,
This is just
what's
pre
the-
and post or pre.
I drew it pre and post.
Do gonna be a bit
Repro. Get the
pre
whole thing.
repro. Post.
What is the /n?
So the /n, there's that /n. I always get confused. with
I
that.
don't know which one's which. I want to say / because I feel like we use / more often.
That makes sense. So this essentially means a new line.
Okay.
So once we plot these two and add them to the figure, we will take these out, see what happens, add them back in, see what happens.
Okay.
Just to visually show what's going on. Okay. So we have our Y label, we have our X tick labels, and that's enough to go on for now. Let's go to the bottom, and let's go with fine tune our figure.
Making it look nice.
So let's grab our canvas. This is going to be set Y label.
Mm-hmm.
This
Makes
is going
sense.
to be Y label.
So this should say, now we should have box charts, box plots with data. And on the y-axis, it should say programming confidence percentage.
So
Very nice.
it is a bit small.
Yeah.
We'll play around with that later.
Yeah.
Let's do the same with our X ticks, set X ticks to X ticks label. Labels.
Very nice. Oh, I see what you're talking about with the new line now.
Yep. So
It's like an enter, essentially.
exactly. So if we were to take it out of pre and leave it in post, you should see the difference between the two. Which can be nice if you have long text and you were to squish your figures together.
Yep. Or you want to make the size of the text bigger.
Yeah. It's another way to rearrange things.
Yeah, makes sense.
Something I like to do. Add it back. And just run it one more time just to make sure.
So we got labels on our X and Y, which is nice.
Mhm.
You want to increase the size next, maybe?
Yeah, let's increase the size.
And then we'll move inside the figure.
Yeah. So we could do it here. Pretty sure we can do it here. It's not intuitive to do it here.
See
what you have to go into the Clarks,
the Clarks.
keyword arguments. But
You don't even want to try size.
I don't want to try size down there. I want to try size in a slightly different area, which makes it a bit more convenient. So I'm going to import the entire matplotlib package again. Matplotlib. Now I'm just going to rename it .mpl, so I don't have to write that every single time.
Makes sense.
And I'm going to change some of the default parameters for the entire package. And those are going to be RC params.
What's the advantage of doing the params?
So by doing this, I can set this once at the top, and this sets the text size, color, even the type to Times New Roman if I want, in one location, and it changes that for all the text and all the figures below.
That's nice.
So if I'm making
You
multiple
can
figures,
unify them all.
yep, it's all unified, it's all the same.
Nice.
Like if I were to recreate the figure right now, somewhere in there, hidden within Matplotlib, there is a text size, excuse me, a text type. All these parameters are already there. I'm
Yeah.
just changing those defaults to something that is a bit more convenient for me.
That makes sense.
So let's set some of these and need to update them to the things that we want. Some of the things I want for sure are font size.
Let's see what this one does.
Yeah, we'll go one at a time with each art.
I like it.
And let's set it to 24. Make it nice and large, easier to see.
So this should make the X take label, Y label much bigger.
Everything, all the text.
There we go. Look at that. I can read it now, but it is cut off.
It is a bit cut off, even if we make it huge.
Whoa.
So it comes up at some point if we enlarge the figure itself,
Yeah.
but I don't want to spend time changing the figure size bit by bit.
Yep.
So pretty sure this is going to be plt.type.
You have to call that before the show, or it'll still work even after the show?
So you do need to call it before the show. And one way to prove that is by doing this.
So it should still be cut off because it doesn't get,
Yeah, nothing has happened because
it
show
showed
is where we're showing
before.
the figure. Yeah. So let's move it up.
Oh, fancy, fancy.
Fancy VS Code, so we can hold Alt
And move lines
things
around.
out.
Wow, that's pretty neat.
All right, let's see what this tight layout does for us.
Oh, nice.
So it reshapes some things. Our Y label is a bit long, so we can do a little thing.
Yeah, maybe a new line on it
a
for
new
it.
line on it.
Yeah, that would make sense.
So let's just cut it in half.
/n. Nice.
And yeah, that should be good too.
Yeah, let's see what happens.
Don't want to make it too big. Nice.
Nice. Programming confidence.
Repro, post repro. Nice.
Nice. What's your what's the next parameter you wanna?
So there's a few things that I do see on here. I do want to jitter these points, but these colors are also.
Yeah, we gotta make better colors.
I don't love these colors.
I'm with you.
So let's specify the colors up here, and I have already specified the colors. Let's just copy these top two for now for our pre and post colors. And this is going to start getting into some tricky territory. Pre, post, and I'm going to package them together. Just like I did with the pre and post data.
Concatenate, if you will.
Concatenate. Color pre. You scroll it
Yes.
to the
Jitters.
up a bit. Up a bit. So first, let's just start playing with the box plots because right now they don't have any color. They're just white, black with a little orange line.
Yeah. So you're going off changing the colors of the box charts first, and then go to the data. Makes sense.
So that's how we started. So we're gonna need a few things, and the items you put on an axis are otherwise known as patches. And I want to set this patch artist to true, which gives us permission to access anything within the box plot, like the overall shape, the colors, outliers, if there were any.
Makes sense.
Let's run it, because this shouldn't do anything right now.
Yeah, it just lets you do something in the future. If you... Whoa!
Filled in the color. I didn't expect that, but
Me neither.
let's change this color because I don't like that.
Yeah. More you know.
So to do this, I am going to first grab the box plots from within the figure itself. And those are going to be, this is the tricky part. So we're going to need a patch, which is going to be each individual boxes that we have. I'm going to assign those patches to some specific color. It's just me adding notes for now. And let me see what else I want to grab from this. So I want to add the patch to change these colors to the color that I've already pre-specified. I also don't love this orange line, and that's going to be the median.
Yeah.
So we're also going to grab the median. So I essentially want to have all of these things together. So I'm going to use the zip function. Let's zip them first, and then I'll go through and explain them. So in the box plot that we have, what did I name? Oh, I never named you. Okay.
So there needs to be an instance of the box plot.
This is going to be a pre-post. Box plot pre-post. And this will be how we access the things within this box plot. And we'll run it to be saved.
Good idea.
Nothing changed, so we're still happy. So we're going to grab some of the items from the box plot. Going to grab our patches, boxes.
And which is really the patch. Just oddly named.
We need to get the colors that we specified on top. And that is going to be these two items.
Create the post
right here. And then we're going to need to access one more thing through the pre-post. That's going to be the medians. We want to change all the colors
of that median bar.
So using this zip, essentially, I wouldn't say concatenates, but structures these three items in such a way that we can access the first iteration of each item when using something like a for loop.
Okay, once you iterate through multiple, that's nice.
It's very convenient. So we're going to grab the box, we're going to grab the color, the color code, descriptive, and make it a bit different than colors. And we're going to grab the median. In our fancy zip that we made. So let's take the box, set the face color. Face color.
So if you were to just run this, it should just change the face of the box, the literal box color, right?
Yeah, this should just set the face color of the box to the color code.
And it loops through both the boxes.
Go through box one.
So if you were to run it, both boxes should have different colors.
Fingers crossed.
Nice. A nice blue and a nice purple. Good choice.
The colors are specified.
Okay.
Another thing that I want is to set those medians.
Yeah, medians were still orange.
Set color. Median. With the for loop, we're just accessing
I think
one
it's
median.
Yeah, there you go.
And We want it black, we want it the same color, let's just make it the same color.
Okay.
We can change it later if it doesn't look nice.
Pop.
That just got rid of my line.
Just
Same color. So now there are two things we can do to kind of fix this. We could just change this to black.
yeah, that'll make it pop.
Let's see how it looks. I'm worried it's not
You
gonna.
can actually just specify black. It does not. You have to say K.
Could say okay.
Oh, that's nice.
It does look a bit nice here, but it's kind of hard to see with the dark background.
Yeah.
So another thing we can do.
Yeah, what are you thinking?
Get rid of this. Oop. Is to do. If we keep editing that box face color, we can now set the alpha or just set the transparency. And I think I want to just cut it in half. Be a bit drastic. No, we'll be even more drastic. See what it looks like.
So the face should be like faded now.
Yeah. So it takes that new color, fades it,
Mhm.
and hopefully shows that median in a bit more of a prettier light.
Nice.
Maybe a bit too transparent-ish.
A little bit.
Maybe I'll bump it up
A little light.
5. But overall, success.
Getting there.
Bit by bit. I think one thing I do notice is that these are kind of skinny.
The
And we have
boxes.
yeah, and we have these fat labels down.
Yeah. And you got a bunch of room on
do
the
have a bunch.
axis.
So I think I want to get rid of our notes. Just set the box width. And let's do it at the top. Box. Box. Let's say I want it to be 0.5, maybe 0.75. Beef it up a bit. Let's just.
So this should make the box fatter.
This should make the box a bit thicker.
Does it start at 0.5?
So this one, well, let me add the width first.
Okay,
and then
yeah.
Change it. Width. Box. Lot. Space. So the size of the width corresponds to the default units of the figure.
Mhm.
And since we never really set the units, so it's just an arbitrarily 1, 2.
Whoa,
If we make them 1 wide, it
the whole
essentially
space.
fills the space.
Yeah.
I want to back it up just a little bit. Maybe 0.75. That looks kind of pretty. Yeah, not
That's
bad.
nice.
So there's a few more things we can do. We can change the color of the scatter points, make them the same, roughly the same color as the boxes,
Yeah, that'd be nice.
and jitter them out. And
Yep.
I think we should be good.
Maybe some grid. Take off the
Yeah,
spines.
take off the spines. We'll save that.
Yeah.
So first, we can just easily change our colors. Let's find our scatter. I'm just gonna add a label down here just to easily come back. Well, scatter plots. So we'll add a label for our box plots. Just so I don't have to scroll back and forth as much. How about scatter? And just C or color. I think it's C. Color green. C equals color. Post. Yeah, see it.
Change the color of the little dots.
Nice. Oh, give us a slight warning. It wants the color instead of C. Good.
It's a lot more descriptive.
I've never learned to C. There it goes. Nice. And I think these points might be on top, might be behind. It's kind of hard to tell. Since it's transparent, you won't really be able to
Yeah.
tell, but these kind of faded.
I think they're a bit behind because, yeah, you can see the black lines on top.
So one easy thing to do that is to mess around with the layering. And I'm gonna do another fancy VS Code thing. So now we're gonna set the Z order, which
Multiple
if you
cursors.
were to place the axis flat, the Z order would be essentially the layer you're putting your paintings on bit by bit. And for the data itself, let's set it to a Z order of 10. Since Python's default Z order is going to be 0 for anything if you don't specify it, I like to make my data positive and any axis, any extra things like a grid to be negative.
The negative puts it on more towards the background.
Negative
Positive.
back, positive forward.
Makes sense. It's intuitive.
And let's see if our data is now on top of those lines, and it is.
Yes, sir.
We can zoom in.
Very nice.
Yeah. They're a bit small though. Oh, so let's do a few more little things. Let's set this is gonna be size. Let's set it to 50.
Make the points bigger.
Yeah, make the points bigger, and I'm gonna do something else and add the marker edge color black.
Why are you doing that?
Just to make the data pop a bit more.
Interesting. Give it a layer.
Give it a bit of dimension. I spelled this. Oh, it didn't like the size. So it didn't like size, but I'm pretty sure it likes S. It should not have restricted. Use marker edge color. You may have to just be edge color. Okay, so it does. Oh, it's this. We'll copy and paste.
Good old copy paste.
Clean this up just a bit to make it pretty.
Oh, cool.
So X data, Y data, colors, right Z order, set the size, edge color. Cool.
Very nice.
Little dimensionality form.
Yeah, you can see the individual ones still scrunched up, especially on the post.
Still scrunched up. Can't really see what's going on here.
Yeah.
Okay, and it's time we jitter them. And then they can play around with the grid. So to jitter them, we need to play around with this X data. Let's just play around with the first one. So we have our X data pre. It's now going to be X jittered data pre. And I guess we'll just take our X data pre. We know which are ones. And we'll add some random numbers centering about. Let's specify how the size of the jitter.
Like how wide you want the jitter to go.
Yeah, and let's make it in ratio to the box width. Let's make it maybe a third. We can play around with that later.
Makes sense.
So we're gonna go back and pull from our random uniform distribution. And this time we want the low number to be the negative jitter width. And the high number to be the positive jitter width. And we want it to be the same. We could do the length of X data pre, but we already know the length of that. We already specified it
And
before.
students and learners.
That's going to be our end lengths. Okay. Let's run it. Shouldn't change the figure yet.
Mhm.
Let's see this there out.
Yep.
Now, let's change this to our X jittered data pre.
So now the point should be all over the place, at least for the first one.
Yep.
Nice. Very nice.
Let's do the same. We will copy and paste.
Gross.
Post.
Multi-cursors.
Post. The beauties of VS Code.
I guess.
Post. We know this is going to be 2. We just need to add some numbers around this 2.
Mhm.
And this is going to be our new data post.
So this should now jitter the post data.
Right around that 2.
Very nice.
Nice. We might change the size a bit, but I think we're good for now. So, one of the things I do notice is I like to add a grid. Let's just add a grid real fast.
Let you see exactly where on the Y it is.
Yeah, I think there's 2 ways to do this. We could just do PLT.grid. Should give us it. It is a bit large, though. I think instead, because we have already, well, first let's see what happens if we raise it above the type layout. Oh, great stories. Because we've already pre-specified our axis and we know that we want a grid on that axis, let's just specify exactly where we want it. And I think it might just be grid. I think it might be set grid.
Like grid on or something like that.
Yeah, something similar. So, I do not love how big the size is, but we can figure that out later.
What do you mean how big the sizing is?
I don't love comes up bit by bit how much space there is between there.
Yeah.
Like the grid's supposed to be there to help you see where actual points are.
Yeah, like you want something at like 25, 75.
Something a bit more descriptive.
I think if you decrease your font size, right, that should help alleviate that maybe down like a 20.
Tight layout that's kind of reorganizing things. Yeah, that's what we want ideally.
Ideally, we can't even see the X and Y labels anymore.
Yeah, we can't see the X and Y labels anymore, but how about we just bring this text size down a bit, then bring that tight layout back. So we know we want the tight layout. And now we'll just conveniently change this one parameter at the top. So 20, bring it 4 points down. There we go.
Nice.
Not bad.
Still big enough you can see it, and you got enough grid lines that you can also discern that.
Exactly. We're getting prettier.
Yeah. Does look a lot nicer.
So we do make these figures for our papers, and typically we want all the size of not the size, but the style of the text match.
Yeah.
And I am not confident I know what this text style is, but I know what I want it to be.
Some people are really good at telling that.
I think I knew someone in high school who was, no, I think there's another lab coordinator who's really good at knowing the text.
I know who you're talking about.
Cool. So let's change the font family.
Different dictionary. You don't have to keep it all in one dic.
No, You're right. I think we could do it separately, but since we already have one dictionary here where we're adding these keyword arguments, let's add language. Font dot family. Family. So I like Palantino. See how to spell it.
You like what?
Palantino. Palantino type.
Palantino linotype.
Palantino type. It's one of those common ones like Arial.
This is a common one?
This is a common one. I don't know if I spelled it
I
right.
don't believe this.
You want to double check my spelling with your internet
Yes.
while I pray that this works.
Palantino linotype.
Palantino.
Palatino.
Palantino.
Tino. No N there.
No N-T-I-N-O.
Linotype. I think that's right.
Type. Cool.
I don't believe you.
What do you mean you don't believe
I don't believe this is a common font.
Yeah.
That is a nice font.
See?
I had
I
no
like it better
idea.
than Times New Roman, but some
It is a bit
journals
more like crisp.
want Times New Roman instead.
Yeah.
But if
Pa-
you want, we can do a
Palatino linotype. Learn something new every day.
Roman. That's what people are more comfortable with, apparently. And we got pre-post.
Interesting.
But
They
either
look
way,
pretty similar.
you can use different texts.
You can set it easily. So if you're in like Arial or something, you could also set that.
Exactly. So I think I'll just change the font size and the font family. Let's bring it back up again. See what else we can change, what else we can add.
It's looking pretty dang good.
Yeah. Got the labels, we got good sizing, jitter scatter points, we can see the medians pretty clear. We got grid lines, we have different colors and the colors match.
You may want to do a little refactorization within your code if you want. If you see anywhere that you want to.
So a good thing to think about when you start copying and pasting things, like I've done a few different times. Like for these scatter points, there's a lot of code here, and most of it's just copied and pasted with
Minor
literally
edits.
one difference.
Yep.
So instead, zoom out just for a second. See where we start copying and pasting. So that would be 1, and that would be 2. We essentially just want to condense that down. So let's start with a for loop up here
Oh,
and comment it out. Bring us back in. So let's start with a for loop. And earlier we noted that there is one difference here and another difference here, and we are just using pre versus post data. Since those are the only differences, we can just do for IDX or index in range. And there's really only 2 items. We could do length of colors, but that's kind of strange to put there. So we know that we have 2 groups.
yep.
I could specify that up here
You can make it a variable, yeah.
in our data generation.
Yeah, I like that. That's a good place to do it.
And underscore groups equals 2. And that's will be what we iterate through. Range and groups. And there's a few things that we want to do. We know we're going to need some X data. So here. We know we are going to make a X jittered. We could do it all in one line, but I like to separate it to make it a bit more clean.
Fair enough.
I guess we can start bringing some stuff in. Ones, it's going to be 1, comma, the size is going to be n, Why there's so many suggestions? I think because I'm too zoomed in. Is that okay for you?
Yeah, that's all right. Appreciate you asking.
No problem. And we're going to add our index. So this should be either 0 or 1, depending on the number of groups.
That should work.
This should be just whatever the X data is, plus some random numbers from a uniform distribution with a low equal to the negative jitter width, and the high equal to the positive jitter width. That's for positive. And it's going to be the same size as the n learners.
Mhm.
Size.
Formatting.
So, yeah, let's finish. We know we're going to plot everything here. Let's do our scatter. Our X data is going to be just X jitter data. Y is going to be data pre-post. They just want to index out one at a time.
Mhm.
The color is going to be that on the index. It's going to be colors that we specified way up here.
Yep.
Way up there. It's going to be just the same things. The rest I'll copy and paste because those don't change.
Regardless of the group.
Yep. Should have just wrote it out. I got lazy. Now it takes just as much time. Colors all in place, black. I think we look pretty good.
Mhm. You need a box chart?
We
Box plot?
will mess around with the box plot next.
So it just should just be data.
Yeah. Now interpret 53 is a data type.
Huh.
Where's our error coming from? 205. Nope, not that.
I think your numpy.1s, that needs to be a tuple, maybe.
Like this is to be.
Yeah. Because I think so it was 2 arguments.
Maybe I should. But now it's a learning moment. And now
This
we know
learning
better.
moment.
Nice.
Oh, the box still there.
Still there.
Thought you commented those out.
Nope, I just commented out the 2.
The jittering. I see.
Zoom out. Let's get rid of all of this.
Nice.
Oop, oop, oop. So that's good. We need to make a function or for loop for any of these guys. Is there anything that was inconvenient to make for any of this?
Any other duplicates?
There's a few duplicates here.
It's okay, just a function call.
I think that's good. Yeah, I think we'll just make a little function call based off these guys. So we will, let's just say create data. I'll be a bit more descriptive. Create confidence data.
Pre-post data.
Create.
What are you gonna do in the function? You're gonna
So-
have it output the 2 data vectors.
I'm gonna have it output the pre and post data.
Mhm.
All right, pre, post data. Given the n number of learners, that's not going to change. Given the pre params and post params. So while you were programming in MATLAB, there was something that I didn't like that you did. I like that you did. Did the pre-low,
Yeah, the variables for everything.
pre-high, pre, post, low.
Helps you get rid of the magic numbers,
Yeah, we don't love the match numbers. Post, high,
make it confusing.
100, this was 75,
55, 0.
5, 0. So this is essentially going to do a really similar job to what's going on here. I'm not going to both of these actually. Generate free data, given. Pretty sure now I can just give it a set of pre-primes. As long as set this up right. Post primes and learners and have it return my pre data.
That's how you get the outputs.
Yeah. And my post data. I actually just want to take it a step further and just return my overall data pre, post.
All concatenated already.
I'll just say data. It's just going to be inside the function. Oh, return data. No. Do generate slash post data and learners, which is going to equal and learners. You already specified up here. The pre-params, which are going to be pre-low. It's actually pre-params are going to be pre-low, pre-high, post params are going to be post-low, post-high.
See it.
Let's see if it works. Oh, shape mismatch.
Broadcasting. What line we on?
It doesn't like that I kept these together. That's okay. I can split them up. I wanted to dream big. And I wanted to see if I could be fancy.
That tends to be the demise of us when it comes to programming, I think.
It's a good learning. But overall, this is just to show a way you can use a function to make your life just a bit more convenient. There it goes.
Oh, look at that.
Never changed.
Still looking nice.
Good. All right. Is there anything else we can do?
The figure looks great. The code also looks very nice.
I think one thing that isn't super necessary, but I do want to kind of fade this grid back just a bit. I can kind of see it through here, and it's not too distracting, but I really just want to put it back a bit.
Fair enough.
So let's just set the alpha. This is going to be the transparency again. Let's make it really faded. Let's go 0.3.
Just an accent, not even something that should be there. Nice.
Might be a bit too faded, but either way, we have an easy way to change that.
Yeah.
So I think that's pretty good.
I'd say so.
Nice.
Now I got to catch up.
I guess we're going back to MATLAB.
Back to MATLAB. Alrighty. Let's see what we can't do. Oh, that's gross.
It's not gross. It's just
Work in progress.
Early artwork of a young programming Picasso.
All right. First, I think you started with your labels, so let's go with the labels.
Start outside, but
Yeah. So I know I want my X ticks just to be 1 and 2 because right now we got 0.5, but we just want it 1 and 2. Nice. I'll make the X tick labels then. You did just repro, right? Post repro. Let's see if that works. I think I need to specify in MATLAB. I need to say that I want the interpreter. I don't think I'm spelling that right. Interpreter. How do you spell interpreter?
INTERPRETER.
I had it right. There's a lot more E's than I thought. Does X tick labels not take interpreter? Let's go to the internet. Documentation. MATLAB X tick labels. What are my inputs? Yeah, it doesn't like it.
That seems inconvenient.
Well,
Probably some intricate, hard workaround that takes a long time to figure out.
there probably is. Let's see if new line works. I think sometimes in the newer code. No, oh, I still got the interpreter on there.
Nice.
Yeah, I don't really like it though because it's not centered. I'm just gonna shorthand it. Let's do pre-batch RR for repro rehab and post RR. Okay, I can live with that. Y label programming. I'm not gonna make a variable for this because I think we're only gonna use it once. Confidence percentage.
Nice.
Yep, we got the XY. Thing I'm gonna do, put a grid on it and then start fixing up the boxes and then the data.
Can you make your text Palantino lunatic?
You know, probably could. I don't think I'm going to though. I think I could, but I don't want to go too far off script.
Okay.
So let's get the grid on. We always want to specify that target. The target makes it nice, and we can specify that here too.
Especially if you were to have multiple
Axes or
targets
figures. Yeah. Nice. I'm okay with how light it is, knowing that some of this is going to change too. So let's do the colors. So I'm going to pull the colors from above, actually. Let's do it after the simulation. Make sure it still works. These are the same colors Dev uses. That's why I'm pulling them. And then let's start adding them in. So it's going to be box base color. First one, and this is RGB pre. RGB post. So now the box base colors should each change. Yep, I like that. Let's change these. I also,
What you thinking?
I don't like, I know we started with scatter, but I'm gonna try to jitter it and I'm gonna try to use one of the newer MATLAB functions. So let's first just go after this one. And I'm gonna use swarm chart. And this is going to jitter it for us. Let's try it just how we had it before, just like this. Looks literally just like what the scatter gave us. So let's give it some more parameters. Let's say the color. Yeah, the marker face color, not alpha. We want that to be free. Yep, so it looks like the face color changed, but the edge colors are still different. Yeah. Edge color, let's make that black just like yours.
Has to be K, not black.
I don't know. I just remember K. Oh no, looks like you probably do both.
Nice.
I like that.
I think there are some instances, like in some special packages, you need K and it can't be black.
Yeah, it's just that's not my favorite, but we'll talk about that later. And then we're going to specify the jitter. We want this as the density, meaning that when there's more points, it'll jitter it further out than when there are less points. I thought.
I think it might be that you may need to,
Yeah, specify
that
here.
may need to be the same size as your line data.
Yeah. You're right. There we go, but now we are pretty wide out there.
You can either expand your box or bring in those points.
Yeah, I can say the width that I want.
Nice.
Let's do 0.5 because I believe the box starts at 0.5 as well. Yep.
Nice.
All right in there. That is what I like to see. It's a bit small, but you know, I'm not opposed to it. So let's take this out. Now I'm going to take this out and do the same thing, but for my post. And I know I just copy and pasted, but I'm gonna come back and refactor in a minute. One thing at a time. There we go.
Baby steps.
Baby steps is right. I'm liking how this is. Let's, because I think this is pretty close to yours, right? Am I missing any components here?
You got the grid, you got your labels. Maybe make the scatter points a bit bigger.
You think so?
I don't think it's necessary because you can still easily count them.
I think you're right, though. We specify size. Let's not do it there. Size data. This one always throws me off.
Yeah,
I want to say like it needs to be like 50.
yeah, I think it's in mine 50.
50 is too small. Let's try 75. Yeah, that's nicer.
Pretty good.
Now we have to give this one same thing, size data, 75. Some nice points. Transparency, I'm okay with that. It's looking good. I like the edge color, makes it pop a bit more. Let's refactor. Let us refactor this code. First thing right here, gross. Two of the same equations, copy pasted. Let's make a function for that. And in MATLAB, your local functions go at the bottom. Well, they don't have to go at the bottom. They can go anywhere, but in Python,
They have to go right before you use them, which
they have to go above when you use them.
yeah.
So you could, like, I see people do it, everything at the top or or you can import, make new files, import.
Yeah,
things like that.
ideally I'd make a new file and import, but I like how you're putting them at the bottom. So like if I have a series of local functions, all I need to do is scroll to the bottom. I know where they are every single
Exactly.
time.
Yeah, it makes it easy to identify.
Yeah.
So in Python, where the keyword is def, in MATLAB, it's function, and you do it's keyword function output equals name of the function parentheses inputs. And in Python, it's def, keyword def, name of the function inputs, and then outputs are given by return statements.
Mhm.
So let's call this generate random uni random, uniform random, uniform random.
You just want to make a function to replace the equations that you have there.
Exactly. Yeah, so I'm gonna give it a low, a high, and an N, or let's do size. And I believe it's gonna spit out some data. So that's the output, let's say, and I believe it's is it high or low first? Low. Low plus
Yeah, plus
high minus low. Whoa. Element wide location, rand size. So let's just run this, make sure it still works. Still looking good. Now let's replace some of these. Data pre is, whoa. Generate uniform random. Whoa. Low pre. High pre. And learners. This is working. It should show the exact same. Wow, doesn't like it. Where don't you like it? And why don't you like it here? Oh, it's a matrix. Ah, that's because this is a size argument. And when I give it here, just the value 53, it becomes a 53 by 53 double, which you can see here. Correct. And we want a 1 by 53. There we go. Get rid of you. You become generate uniform random, low post, high post, 1, and learners.
Nice.
Looking good so far. Colors, let's add some commas. Be fancy. Always run in between, especially if it's a short script. Now I'm gonna tackle this component. I'm gonna make a function that will do a box chart and data all in one. Let's call it. Whoa. Function plot box with data. And it's going to take in X, say value, and Y values.
Probably your target too.
Yes, that's a good point. Axis. So, and it's gonna need the color. So, how do I want to do this? Let's first bring all of this, or I'll bring all of it and then I'll take out, so it's just one. I don't know.
One box chart, only one swan.
Yeah.
One figure general.
So we've got this repeat elements 1 by n learners, and we no longer have access to n learners. So let's just say n values, I guess. And that's just going to be the length of the y values because we know that that will be a vector. Whoa. That can go here. The X value, that's really the one. X value, so I'll replace both of those.
When you say it's the one, it's the
X tick,
X stick
the X value, yes.
where you want your data.
On the axis, yeah, exactly. And then the data is going to get replaced by the Y values. And then the color, we're going to take that out. We'll always want to hold on so we can leave that here. And the rest of this works anyways.
Do you ever hold off, or do you ever need to hold off?
I typically don't hold off. I think hold off, you know, if you want to, like, if you're adding text to a figure, sometimes it's nice to hold off. So you can keep kind of replotting on it without it holding all of the different text objects.
Makes sense.
Let's run this so far. Still looks the same. Really, we didn't make much of a change. Let's take a leap here and take off this first one. So now it should just be the second one. And let's try to do, what did I call it? Plot box with data. Yes, I did. Plot box with data. This axis, X value is 1. Data is the pre, and the color is RGB pre. So now this should have both on them, if I did it right.
Nice.
There we go. Let's take this out. Take this guy out. We don't need to still hold on because that's already within it. So we'll just call it again with our post data. Let's comment this out. There we go. It's coming along. It's coming along. And, you know, if you wanted to make edits, you could also take the handles as outputs like this. But I'm not going to do that because that isn't what we want.
Yeah, no need for it today.
No need for it today is correct.
Looks very good.
Now you got this clean script, all your parameters set up top. Easy single function call that can be reused later on. Just some minor edits there.
Can I see the figure one more time?
Yes, we should end with a nice figure.
Well, I don't want to end yet. I do see something in your figure
Tell
that
me,
I want to do too.
what do you want to do?
So I'm curious, does your figure automatically take off that top and right black line that we saw in mine?
I put that in a setup file so that it will always do it, but
Oh.
typically MATLAB does not.
So you have your setup already like good to go, and you didn't
Yeah, I
think about telling us, huh?
I did not. I wasn't going to tell anybody.
Well, I'm gonna go to Python, and we're gonna do that real fast because my figure doesn't do that.
So you got to do it each time.
I gotta do it every time, which I'm okay with. Sometimes I want it, sometimes I don't. Oh, that's it.
Ooh, it's a good looking figure though.
It is pretty good. Share the whole screen.
There you go.
Back to our figure. What I was talking about is taking off this top line and this right line, which I know it has a silly thing. We're gonna take the axis, and it's gonna be, what is it called? Spines. Spines of the figure. And we want to take the top spine and the right spine. And set visible,
Just make them invisible.
false.
Good old boolean.
So one line of code, not too much work.
Easy peasy.
And sometimes, like if you wanted to make an exemplar figure, you could turn off all the spines, which
Mhm.
we've done from time to time.
Yeah,
Nice.
very nice.
Took them all.
Easy.
Yeah. I'd publish with that.
I'd publish
pretty.
with that too.
Yeah.
Yeah, that's good data.
Yeah, it's pretty good.
Very accurate.
So I guess we're done with Python and MATLAB for video one.
That's our, yeah, I think that's our first video.
Well,
Thank you for watching.
exactly.
And we'll show you, well, all this code is going to be on GitHub. We're not going to plug it right now, but it's on the Repo Rehab. It will be on the Repo Rehab GitHub. Well, the next video we're going to add to this figure. And we'll show you exactly where the code will be. So
Thank you for watching again and look forward to the next video.
see you in a bit.
Bye-bye.
Bye-bye.